Hello all, I'm Suresh Chandra. We are having a team, and my teammates are Akshay and Sriram. And we choose a project for the capstone in 4-1 session, and the project we choose is related to pneumonia detection using AI and deep learning. I am very much excited to host you the presentation. First, let's get the overview of the problem. Pneumonia is a serious slug infection. It's an affecting millions of people in each year. The major problem is that most of the people could not even realize that they are affected with this problem and they are gonna die soon. And we think it's a state level problem or a national level problem, but it's not actually. It's a very global burden where 100 million plus people are affected each year. It's a quite a big number. It's almost equivalent or even in fact more than most of the deaths attempt by COVID virus as well. But this wasn't realized or understand by people till now. And being this much being having this much technology, very much advanced medicines, and can even have the best cure for this, the problem is that people really don't know what is pneumonia is. It's a simple disease where people lungs will get filled with watery substance so that they can't be breathe as a normal human, and end of the day they're gonna die. It sounds like very simple or an awkward to hear, but it's so disgusting that millions of people are dying, not even knowing the reason. Like they just think like it might be some heart attack or any health issues, but they even don't know. But if we can able to make them realize that they are affected with pneumonia at the beginning stage, there is a multiple ways to cure them, which helps them to get cured completely within over a period of very 6 months or 1 year of time. But the problem is that people really don't know, and most of the people don't have enough money to go to a super specialist who can figure it out that whether he or she is suffering from pneumonia. But we find have a solution for that. Before I'm going to explain you the solution, let go through the diagnosis challenges. First thing, there are very much shortage of specialists in regarding X-ray and specified regarding to pneumonia detection, and it's been expensive nowadays to go and have an appointment over the specialist regarding this kind of medicinal practices. So people are not willing to pay 1,000, 3,000, or 5,000 for a specialist to just verify that they are suffering with these problems or not. So this is a major issue we are being faced from years together. And we find a very innovative solution. Being a CSC students, we have a solution for it. As AI being a revolutionary nowadays, we gonna find solution with AI as well, where we just input the X-ray or a digital scanned copy of a human lungs in our project, in our source code, and within fraction of seconds, you'll get to know that whether you are affected with pneumonia or not. If you are affected, at which stage you are at. We'll even intimate you that. So, if we confirm that you are affected with pneumonia, then you can go to a specialist and get cured immediately. If not, you can happily continue your life. It sounds very simple, right? Most of the people will get x-rays for the reasons like cold or even lung infection or basic things. They will get the x-ray of the lungs very casual because it costs around 200 to 500 ranging upon the diagnostic centers. So it's a quite a bit easy task for them to spend 3 to 400 rupees on their x-ray, which can even be used for their regular health checkups, as well as an extra source of knowledge. They can even input this issue in our project where we find a solution that whether they are affected with pneumonia or not. And the question arrives like how the AI works. Can we trust the AI? Is it more accurate or not? Well, I cannot guarantee you 100%, but I can assure you that more than 90 to 95% of the success rate we going to maintain till the project. And the point is that it's always better to have something than be nothing. You just don't have any idea that you are affected with pneumonia or not. But if AI just recognize that you're starting or you are having a basic level, it might be done some mistakes, but at least you are going to have an advanced checkup than a rather usual checkup. So if you're struggling with stage 2 or stage 3 of the disease, and my device or my project can only recognize it as stage 1, well, it's even fine because it's intimated that you are being affected with pneumonia, then you will be definitely going to a doctor. So it's a life-saving issue where you get realized that you are being affected with a disease. Yeah, it is serious issue, but the best part of it is like we have a solution for it. There is a treatment for it. You just go to the specialist and it works within an year. And now we use convolutional neural networks CNN specialized for image analysis, trained on large data sets of X-rays labeled as normal for our pneumonia. We included to the system hundreds and thousands of images of X-rays, inclusion of thousands of X-rays which are affected with pneumonia and thousands of X-rays which are not affected with pneumonia. So our system data analyze the whole data and uses this to run with the each time with when you upload a photocopy of your X-ray, the system runs and go through all the possibilities of pneumonia detected X-ray copies. Is there anything matching exactly or not? If it is matches, then it will be triggered you that you are affected with. Assume that a project had made a mistake like you are affected with pneumonia stage 1 or stage 2 and you have feared and you went to a specialist and you check it out and you are not affected with. It's fine. It's fine. You take a moment and there is a very low out of low scenario that if you are affected with pneumonia, my project would not be able to recognize it. With the highest possibility is that the lowest level of pneumonia detection can be done through AI, not by the humans actually, because we cannot even identify the exact differences in the X-ray copies. But the AI can do it very simply. Even a 50 years experienced doctor might miss out few points regarding eyesight of his problem or what, but AI would not do it. So we can trust AI rather than a specialist nowadays. So I believe in it. And the datasets we used are publicly available datasets. We took it out from the NIH, RSNA, and the Kaggle, very famous one for the regular datasets to be used in the project. And we also contacted our professors regarding this issue and also contacted a medical officer and showed up the datasets of this copy, like whether this is good enough or not. When well, he even accepted that. And the point I want to explain that normal lungs and the bacteria, pneumonial cases, and viral pneumonia cases. These are the subjected in our data list centers. And pre-processing steps will include that resizing to uniform dimensions. Most of the people would think that, okay, you are mentioning that you mentioned most of the X-ray copies. Like, can we see that? No, you cannot. It will be in a different format where we included it as data sets, not as the regular images we upload in our photos or videos. So normally you cannot say it. Only the system which we include, which we enhance it into the, we can able to check it or we can able to change it. You will be just having the output of us. And the model architecture, we used it ResNet, DenseNet, and EfficientNet. And the architectural components coming part, convocational plus polling layers for the pattern recognition, fully connected layers for classification. And we even explainability with GradCam highlights lung regions used for the decision, which increases doctors' trust and transparency. If you go to doctors with our report, there is a high chance that he'll even clarifies you. If there is an issue like with a project, please come and say us, we'll update you. And we'll work on us to get improve day by day. And performance metrics. We definitely highest accuracy score we ever scored is 95 to 96%. The minimum score we scored is 90%. So I'm can 100% sure I can confirm you that we have 90% plus accuracy rate in identifying all the pneumonia cases. In high sensitivity cases, it's almost more than 96%. In a low sensitive stage 1 cases, it is around 90%. So it's way better than all the available products in the market. We go through many of the existing projects where we concluded that the highest possible rate of success is being listed out around 75 to 85%, and we are so much happy to announce you that we are scoring 90 to 95% success rate on it, and we are on to the it. And the stage analysis, there is different stages of pneumonia. Mid pneumonia, like small patches of opacity, it's a starting stage where it can be cured within just a regular medicine and few weeks of doctor consultation. Next, moderate pneumonia, multiply affected lungs once. You might feel it, but it's fine even now. It can be curified within weeks as well. Severe pneumonia, large consolidations, and needed urgent care. It's a very rare part until a severe pneumonia case, if you didn't act accordingly or didn't realize that you are affected with it, it causes severe damage to you. But thanks to our medical technologies, even now they can cure you. I would say that it's not that easy to cure you with the severe pneumonia or severe prediction, but way better. At least when you recognize it in the final stage, there is a highest possibility that it will be cured to normal. And coming to the deployment, it's not mandatory the user who is using our project to be used only laptop or PC. It is available in the mobile app as well, and even hospital management systems. And even small hospitals or the clinics, they can use our copies. Small RMP doctors or small medicinal clinics where they don't have the enough devices to identify it, they can do the basic test in a project as well, and they can go through the suggestions like if there is any emergency or there is any serious concern, they can go to the higher doctors or the specialists. Steps is very simple. Even a normal person who just holding a smartphone can use it. Just upload your X-ray copy, and AI process the images, and AI will display the prediction plus highlighted lung regions through which you would realize that is your lung normal or something that is serious. You can even analyze that, and works with the low resolution X-rays, portable X-ray devices, PHCs, and small rural clinics. It might be, some people might think that I took the X-ray in a very remote area, very a village-like area. I don't know whether the X-ray quality is good enough for the system to process. Well, we trained our AI with thousands of images, which in inclusive of high resolution, inclusive of the very lowest resolution, which is high, most probably lowest resolution than the copy you uploaded. We even tested AI with most of the vulgar conditions as well. So it's completely fine. You upload it to the highest quality. Don't use a camera which makes the image blur. I realize that if the X-ray is blur, it's fine. But try to make to sure that you make a image or you take a photoshoppy or you take a photocopy of the X-ray very clearly and a very good or bright light. That's more than enough. And the advantages, firstly, it's affordable. It's completely affordable. As of now, we charge nothing. In future, we charge 50 or 100 rupees. That's it. It's a very, very, very fair and lowest price we can offer. As of now, it's completely affordable. It's free. Just you have an X-ray copy, which costs you around 300 or 400, and that is more than enough for you guys to go to the process. And accessible. Every corner of India now people are using 5G mobiles, not even 4G. They are using 5G mobiles, which is more capable than this. So it's completely fine and accessible to almost millions, not billions, almost accessible to billion of Indian users. And the fast results, like you just upload the copy and just think like are you affected or not with the pneumonia. You just have an idea of it, and the RAI will show you the result as well. It's affordable, accessible, and super fast. And now I want to conclude my th- project that AI provides early, accurate detection of pneumonia using just simple X-ray copies. System reduces workload on hospitals and radiologists, makes diagnosis quick, affordable, and accessible. Can be scaled across government health centers, private clinics, remote rural areas, which is indeed a lot, has potential to save thousands of lives through faster intervention, and the process very simple. Thanking you. And now I'm handling to Kodal Akshay to go on to explain to the code of the project.
Yeah. Thank you, Suresh. So I'm gonna tell the code of our project. The pneumonia detection, the website was created to end-to-end system designed to classify the chest X-ray image as either it was affected by pneumonia or a normal using deep learning. The entire project is built using a combination of Python, Flash, TensorFlow, Keras, React, and CSS. The technology is its own purpose, and together we have to create a reliable, interactive, and scalable solution. We developed a machine learning model using Python because Python is the most widely used language for AI and provides the scalable libraries for image processing and deep learning. The core library used for training the pneumonia detection model is TensorFlow with Keras, which allows us to build a CNN in a simple way and structured. So, CNN is the ideal type of neural network for the medical image analysis because it can automatically detect the visual patterns like shadows, spots, and texture difference, like to help the identify the pneumonia in X-ray scans. To prepare the X-ray images, we spotted a Python library such as NumPy for numerical operations and Pillow for the image loading and resizing. The backend of the website is a Flask lightweight Python web framework that allows to convert the deep learning model into a web API. Flask is used because it is simple, fast, and integrates smoothly with Python based on machine learning models. The API includes the prediction endpoint and which accepts the to upload an image, process it the exact format, the training models and experts, and run the prediction. And for the backend also interacts with MongoDB to store the prediction records. MongoDB was used because it supports the flexible JSON type documentations, or it is easily to store the unstructured prediction data like data or image name or a model confidence. The frontend is used for React, a JavaScript library that helps us to create a modern, clean, and responsive user interface. React is used because it allows to build usable components and handle user input smoothly and communicate with the backend API efficiently. To style the website, we use the CSS to provide a web and utility-based styling system that helps create and to clean the layouts, especially, and to responsible design without long CSS files. Together, React and CSS gives user initiative interface where they can easily upload and predictions. The step-by-step process of the website is very simple and user-friendly. Firstly, the user visits the homepage of the pneumonia detection system website. They will upload a section where they can either click or browse image or drag the image of a X-ray file. Once the image is selected, it is the displayed, it displayed the screen and confirms whether it is a correct file or not. After this, the user clicks the prediction button and which sends the image to the backend image and API cell. The backend image is received, the uh, converted the required size or normalized and personal passed through the deep learning model. Overall, the combinations of deep learning for medical image classification with a fully functional web interface. Each technology like Python, TensorFlow, Flask, React, and MongoDB, which uh, which plays the especially the role and make the entire system efficient, accurate, and easy to use it. If you see here, we have created, we have uploaded a normal X-ray, which we don't know whether it is a affected with pneumonia or not. So here the confidence level was 97.78 and it was not affected by pneumonia. But whereas if you share the another uh, where the pneumonia is affected or not, it shows the exact image and you can see the screen. So The X-ray was detected by the pneumonia and it was fully damaged. So the person should go to the hospital, consult a doctor, and he will explain the complete details and he will give the precautions for that. That's it about this code. And now I hand over to Sriram regarding the documentation. Thank you.
So thank you, Akshay. Now I'm going to tell you the complete documentation of our project pneumonia detection using deep learning. So let us go to the this is the acknowledgement, the documentation of the guidelines which our college has shared. And here we can see the table of contents. So coming to the contents part, here we can see that abstract about the organization or company, that part and introduction of the project, literature survey, problem statement, requirement analysis, risk analysis, and feasibility analysis, and proposed solution or approach or technique, architecture diagrams, flow charts, DFD, simulation setup and implementation, visual comparison analysis, learning outcome, and conclusion with challenges and references. So here these are the uh, interfaces we have used, like AI, CNN, ML, GPU, and for extra images we are using here radiographic images and graphical user interface for the website. And there are some data sets which are taken from the Kaggle, TensorFlow, and Keras. So the major abstract of this complete project is here. It is mentioned that regarding pneumonia detection using deep learning by mm, inputs of CNN with the help of Python. And coming to the basic introduction here, uh, using artificial intelligence and deep learning, how pneumonia is detecting nowadays, and by the comparison of past and present, how the AI powered is generated in this pneumonia detection. Here we shown it, and the through this chest X-ray, how that data set is loaded and how the images are showing. Here we can see by process. And this is the basic history of how pneumonia is detected in past and how pneumonia is uh, like what are the benefits and disadvantages of that. Here we can saw, and there are some thesis papers also written by some experts. I mean, it was implemented in the past in 2019, 2020, and 2019. With these references, we took some examples and some real case studies. So this is the system study and the proposed system. As just now I said, we have took some references from past, and also here we used, as I already said, here we used Kaggle dataset for image representation. And the major problem statement here we can see that as early my friends are also said that the detection is not going in a process in the proper way. So here the in the problem statement we can see that, and these are the functional requirements, that how the image is loading and how the data set is loading. In that we can see that in all requirements we can see that how it is loading. I mean, the advantages and disadvantages can also be observed here through these functional and non-functional requirements. And coming to the hardware requirements, here we use how the NVIDIA graphic is like executing here, and the language here we used is Python. And for the interface we used here HTML, CSS, and JavaScript, as we all already know that. So we need to observe what are the risk analysis we can face. Coming to the software and hardware components, as I already said, the comparison between description and mitigation strategy you can see here. So what are the risks are facing and what are the statistics are observing here. So this is the structure we can see here, how the backend process is going on. We can easily observe here. So for the basic problem statement here, by using CNN, as we already know that CNN means convolutional neural network. So by this architecture, we can solve the problem easily, as we already got 90s above percentage here. And these are also the some of the extra specifications we can see here, like how the display and how the interface, overall interface is looking, we can observe here. And here some basic frameworks we are also used, and majorly the whole code is run in the Jupyter Notebook and Visual Studio Code also. So the data collection and data processing will be managed by the entire code. We need to observe that. So in this module, some predictions will be arised. We need to check that so that the exact image processing will happens. And also these are some example data sets where we can compare both Kaggle and other data sets also. So majorly this is the numerical analysis. After the output we can see. So after the test sample has inputted in the code, we can see the major ratios are 80s and 90s. So at the first we have got here 85.4, and then by the increasing the count we can get 93.2. So the average prediction is also comparatively analyzes here. And there are some solutions we can also implement here, like proper pictures, and see if we observe here, this is a normal picture and this is the pneumonia affected picture. In the result we can compare both images. See, the first picture here, it is normal picture as common man's, and here this is a pneumonia affected. You can see the difference between both images here, and this is before and this is after the input. In the output we'll be getting like this. So this is overall, this is our website, how we develop. As just before, Akshay also practically shown you. This is overall technology we use here, and you can see this is the major part over here. After uh, importing the photo here, the X-ray here, we can see the immediate result over here. Either the person is affected with pneumonia or not, we can easily check there. And after that, we may also consult to the doctor, depending on the result. And so the major accuracy here we got in 90s, because in medical fields, most of the projects should get uh, about 96 to 99 percentage of the accuracy. So at the same time, we also got here. And coming to the conclusion and challenges faced here is, due to it is a medical field project, we have searched many references. You can observe here, these are our references. So as this is the medical field project, we need to observe most of the cases and comparative past cases also. It should be somewhat benefited to the society also. So coming to the conclusion, we have done our best. Thank you.
So thank you, Sriram. Thank you, Suresh, for this. And this is about our project, complete details, and the prototype we have shown you, and the website. Soon we gonna publish this, and soon we gonna write a research paper on this. And that's it. Thank you so much.